All right, so this is part 2 of 2.5, exponent laws. We're still going with exponent laws. We've got kind of 2 more to cover today. So on the notes in front of you, you have now a power of a product. If you look on the left here, it says the power of a product. Yeah, am I frozen? I am frozen. Now, I'm not frozen. Okay, thank you. So yesterday was power of a power, right? Power of a power. When we have a power of a power, we what to the exponents? Multiply, very good. So this is now a power of a product. So what does that mean? Well, that means we have a power, but the base, I guess, so to speak, is a product of 2 factors. Okay? A product of 2 factors. Now, this could also be written like this. 2 times 5 is 10 to the power of 3. That also could be written like that. All right? So this is going to be important because any power can be written as a power of a product, because you can just factor this 10 and rewrite it in different ways. So 10 can be written as 2 times 5. You see that? So these, in essence, are the same. All right? Now we know what this value is. Do you know just offhand without the calculator what this value is? Yep. 1,000. Very good. Okay, so this is going to be 1,000. Maybe it doesn't look like it, but let's focus now on this power. And let's expand it, okay, so that we can, and the first row is done for us. So, all right, so 2 times 5 to the power of 3. Well, that means I write the product of 2 times 5 3 times, and I multiply those. I multiply each of them, okay? Excuse me. Now, because this is a product, and we have a whole bunch of things that are multiplied together, I can change the order of any of those factors. They're all called factors, okay? When they're individual pieces of things that are multiplied together, each of those pieces is called a factor. So if I have a row of factors that are multiplied together, I can actually rearrange those factors in any order, because when you multiply them all out, you still get the same answer if they're in a different order. So what we've done here is we've grouped the 2's together. You see, there's 1, 2, 3 2's. And you could just rearrange this a little bit so that you have all 3 2's multiplied together. And then there are 1, 2, 3 5's as well, and we can regroup those. And now what this looks like is 2 to the power of 3 times 5 to the power of 3. Okay? So that's how we work through this power of a product. Let's do it again. Let's do it again with this next one. Okay, so 3 times 4 squared. I'm going to write that as 3 times 4. I'm going to use my little dot because it's a little easier for me to use. And I don't like using x's anywhere else other than just for a variable. So 3 times 4 times 3 times 4. Okay? Guys got it? Understand? Okay. Now, because these are all factors, these brackets, they can actually be removed, and this is just a straight multiplication of 4 things. And I can rearrange those any way I want. So 3 times 3 times 4 times 4. And now if we look at this grouping like this, that's actually 3 squared times 4 squared. All right, so we've got 2 things to look at here. 2 times 5 all cubed is the same as 2 cubed times 5 cubed. 3 times 4 all squared is the same as 3 squared times 4 squared. So you may be picking up a pattern here. Let's do another one. This one's going to be a long one, so we'll do one more long one here for sure. This is 4 times 2 times 4 times 2 times 4 times 2, and then we're going to do this 5 times. Times 4 times 2 times 4 times 2. And of course these are all multiplied together. I'll put my dots in there because we're going through 2 different lines. And when we rearrange those, I can write this as 4 times 4 times 4 times 4 times 4 times 2 times 2 times 2 times 2 times 2, which is 4 to the power of 5 times 2 to the power of 5. So 4 times 2 to the power of 5 is the same as 4 to the 5 times 2 to the 5. Are we recognizing a pattern here so far? Okay, let's do one more with a negative exponent, because those are always tricky, right? All right, so let's do 7 times negative 2. I'm going to use my double brackets here. And we're going to do that 3 times. 7 times negative 2 times 7 times negative 2. Rearranging all these, putting the numbers together that are the same, I have 7 times 7 times 7 times negative 2 times negative 2 times negative 2. And so the final result is 7 cubed times negative 2 cubed. And that's probably the last example I'll do, because I think you can kind of see 7 times negative 2 all cubed is the same as 7 cubed times negative 2 cubed. So can anyone take a stab at what the pattern is here? What would you say the rule or the pattern is? Yeah, Michelle.
It's, you take the exponent and you have your two numbers and they're both turned into a base, and you just put the exponent for both of them.
Okay, very good, very good. You take your two numbers that are multiplied together, and those become two separate bases for the exponent here, right? There's a bunch of different ways you could put that. The exponent is applied to, you could say that, to each factor, or to each number, or to each quantity, because it could be a letter too. And we'll get into that later. We'll just focus on numbers now. But it could be a letter like X or W or Y or K. And that exponent would be applied to each factor inside the brackets. So this one here, without writing all of the steps, this is going to be what? I can rewrite this as what? You guys shout it out. 5 squared times 6 squared. That's exactly right. Okay. Now, okay. So I've got I got 2 lines that are the same. Okay, so this one is the same as that one. All right. Let's go back up. What's this one? 5 times 3 all to the power of 4. This is going to be 5 times 3 to the power of 4. Excellent. Okay, you're getting it. All right, so let's move on. The next page gives us the exponent law for the power of a product. So let's just focus on this. I think you have a blank to fill out here. So here's the one way of putting the rule as well. When you have a power of a product, the exponent outside of the bracket is applied to the exponents on each of the factors. Okay, so that's a little bit next level there, but it's applied to each factor inside of the brackets. And this right here is really important. Okay, this right here is really important. If you have two numbers that are multiplied together inside the brackets like this, and they're all taken to an exponent, this can be rewritten as 1 factor to the power of that exponent times the next factor to the power of the exponent. Okay, now A and B can't be 0. We know there are some restrictions to these rules. Okay, A and B can't be 0. But that's the rule. Now, we're going to do some practice here on these, and then I will kind of just show you some extensions as well to this rule. But let's just get some practice here. All right, so identify the factors first of all inside the brackets. The first factor is negative 7. The second factor is positive 5. So this exponent applies to this factor, and it applies to this one. And sometimes I like drawing those little arrows just to show that, hey, this one's going to apply to this factor. So I'm going to have negative 7 in brackets squared times 5 squared. Now it says evaluate each question in 2 ways. Power of products way that we just learned, and bed mass. So here is... it says evaluate. So what's negative 7 squared? Do we know that?
49.
That's going to be positive 49. Very good. And 5 squared is? 25. Okay. So that's a little bit big to, I mean, we could do this on our calculator. That's no problem. So that's going to be 1,225. Okay. That's using our power of products way. Let's use bed mass. Okay, what is negative 7 times 5? Because we have to do, bed mass says we have to evaluate inside the brackets first, right? So negative 35, good. And then all of that would be squared. So this is the second method, evaluating what's inside the brackets first. That's the second method. So what's negative 35 squared? Well, that's going to be negative 35 times negative 35 is going to be, oh, look at that. 1, 2, 2, 5. There you go. So the rule seems to work here. Everybody see that? Okay, let's do it again over here. This negative sign, is that part of one of the factors in there? No, it's outside the brackets, right? So the exponent here does not apply to the negative sign. You have to remember that. So I'm going to leave that negative hanging outside here. And then I'm going to write 3 squared times 2 squared. So that's going to be negative 9 times 4, because that's what 3 squared is 9 and 2 squared is 4. And so that's negative 36. Okay, so that's what the first method tells us. Now let's see, I'm just going to rewrite this as it's written there. Okay, so BEDMAS says I should do brackets first. So this is a bit different in that I say negative, and then this is positive 6 inside there, squared. Again, that negative is outside the brackets, so the square does not apply to it. So I have negative 36. All right, any questions so far about this? No? Okay. All right. Wait a minute. Is there, oh yeah, there's some more down here. Okay. All right, so I want you to take a moment, please, and I want you to do these 2 questions. Okay, on your own, do those 2 questions, and you can evaluate using any method of your choice. I would suggest you show that you know how to use this new rule. Okay, so method 1 there, using the exponent laws. But go ahead and see if you can evaluate this on your own. I'll show you the answer in a minute. All right, B might be a little bit tricky, so I'm going to go through it with you here. Now let's go back. Let's go back right here. Notice that when I read this exponent law for the power of a product, I said, I read this and I said, well, this is a bit of an extension. We'll go over this later. So the exponent outside the bracket is applied to each factor, but notice what the wording here says. It's applied to the exponents on each factor. Technically, that's the full definition of this exponent law. So what does that mean? Well, that means that if there are exponents already inside the brackets, then those exponents are applied to the powers that are inside there, including the exponent. So watch this. You go like this. This 3 is applied to this power. So that's actually negative 2 squared to the power of 3. You see that? So that whole thing has got the exponent. So we've got, here we go, there's our, that's in there. And then the 3 out here is applied to it. So that's step 1. This is getting a little complicated, so pay close attention. Step 2 is this. Negative 2 to the power of 1 to the power of 3. So that 3 is also applied here. And what's really super important is to know this, that when you apply the 3 to the power, you don't apply it to the negative 2 and to the 1. You don't do that twice. It's just now the power of a power. Okay? So we'll do some examples to try and help you out with that. Shh, girls. No talking. No talking at all. If you have a question, please wait and ask the question. Okay? I don't want you talking while I'm talking. Got it? Okay? All right. If you have a legitimate question, please wait and ask, because others might benefit as well. All right? But I don't want constant talking while I'm teaching here, okay? So this is negative 2 to the power of what? Yeah, now our former rule takes over. So this is negative 2, the whole thing, to the power of 6. And this is a tricky one to do first with the negative sign. It's a little bit, there's more brackets and stuff. But this 3 now gets applied to this power, and so how we do that is we multiply 3 times 1 here for this one. So this is negative 2 to the power of 3. We'll do more of these. I think we need to do more of these because this is a little bit, this is a higher level, a little tricky. So now we do our product rule, and it's -2. Do I add, subtract, multiply? What do I do with these? Yeah, you bet, I add. So that's -2 to the power of 9. Now, powers of 2, you should be pretty good at powers of 2. We could, even if you don't have 2 to the 9 memorized, which I don't even know if I do, I don't think, I would have to like work it out in my head too. So what do you know? 2 to the power of what? What's the highest power that you know? Memorize. 2 to the power of, anybody? 6? Okay, what's 2 to the power of 6? 64, okay. So 2 to the power of 7 would be 128. 2 to the power of 8 is 256. So 2 to the power of 9 is 512. And if you guys are computer people, those numbers should be familiar, right? So 512. Now, is this going to be a positive 512 or a negative 512?
Negative.
Yes, because we have a negative here taken to, like, multiplied by itself an odd number of times. So it's going to be negative 512. Okay? And just really quickly, that's -2 times -2 times -2, 9 times. Okay? So 5, 6, 7, 8, 9. Okay, that's what that is right there. 512. All right, let's do a couple more examples before I get too far into, let me see. Oh yeah, I got to do this power of quotient too. A couple more examples, okay? It's going to be a bit of a bigger lesson today. So write these down, please. Examples. Okay, so let's do 2 cubed times 3 squared to the power of 3. And we'll do one more over here. Okay. So write these two down here. And yes, I do EG for those of you that are not familiar, have been in my class before. This is example. I know it's not spelled that way. I just do not like using x's for anything other than for a variable x. So that's why I don't do the multiplying but with an x. That's why I don't write even example with an x. I don't want any other x's on the screen other than variables. That's I try and avoid that. So that's why it looks funny. All right, so according to our rules here, we are going to use our exponent law, and I'm going to apply this exponent outside to each factor. Okay, that's what I'm going to do. And so what this looks like is 2 to the power of 3 times 3 times 3 to the power of 2 times 3. So I multiply these factors. This is like a power to a power, right? A power to a power. So that power, that exponent outside applies to each factor. There could be 2 factors or 3 factors or 10 factors, doesn't matter. It applies to each one separately. As long as they're multiplied inside, as long as it's multiplied, it can apply to each one. So this is going to be 2 to the power of 9 times 3 to the power of, whoops, that 2 disappeared on me, look at that, 6. Okay. Now, to evaluate this, you would have to do this separately because there's no rule now because the bases are different, I guess, right? So there's no rule where you can just add exponents or anything. So 2 to the 9 we just said was 512, right? 3 to the 6, that's going to be one you'll have to put on your calculator. That's going to be 729 times 512. It's going to be a big number here. That's huge. 373,248. Big number. Okay, if we were to evaluate it. Now, in your textbook or on your test or whatever, it just may say, show as a product of powers. And there you go. That's all you'd have to do. You end there. And this is evaluate, right? So that's evaluate. This is show as a product of powers. Okay, so depending on where you can stop. Ooh, you can't see that yellow very well, hey? No problem. I won't use yellow. All right, so let's do this one real quick. This is -2 to the power of 1 times 2, right? That's 1 times 2. So this one goes with this. Take care of that first. And then I have times 4 to the power of 2 times 2. This one is applied to this power second. This is going to be -2 squared times 4 to the power of 4. This is going to be 4 times 256. 1024. All right, so again, you can stop here if they ask for, write this as a product of powers only, and stop here if they say evaluate, okay? All right, pause for questions. Pause for questions. Yes? All right, next stage. We got two concepts to cover here today. So next page in your notes, power of a quotient. So these two exponent laws, very, very similar. We're going to do these together. The concepts are very much the same. You'll see this right away. All right, this one is called power of a quotient. Power of a quotient. Now a quotient, if you remember, is the result when dividing, right? The result when dividing. So on the chart here, I have a quotient. This is a quotient right here, this 5/6, okay? That's a quotient. And I am taking this quotient to the power of 3. That's why it's called the power of a quotient. In repeated multiplication, we can write that out as 5/6 times 5/6 times 5/6. Hopefully you remember this from elementary school, but when you multiply fractions, you don't have to get a common denominator first. That's when adding or subtracting. But when you multiply fractions, you simply multiply the top numbers and then put that all divided by the multiplication of the bottom numbers. So you just multiply straight across when you multiply factors. So that means that these three fractions, when multiplied together, can be written as one fraction. It's the same as 5 times 5 times 5 on the top, which is called the numerator, the top of the fraction, divided by 6 times 6 times 6, which is the denominator. Okay? And that can be written, if you notice, this grouping of 3 5s multiplied together can be written as 5 to the power of 3. And this grouping of 3 6s multiplied together can be written as 6 to the power of 3. So here we go. We have a fraction to a power, or a quotient to a power, is the power of the numerator divided by the power of the denominator when that exponent is distributed. So let's do another one. 2/3 times 2/3 times 2/3 times 2/3, 4 times. That can be written as 2 times 2 times 2 times 2 on the top, or the numerator, divided by 3 times 3 times 3 times 3, or on the bottom, the denominator. You group those together, that's actually 2 to the 4 on top there. You group these together, and that's 3 to the 4. So I have 2/3 all to the power of 4 is the same as 2 to the 4 divided by 3 to the 4. So you might be seeing some similar patterns, right, to the factors, okay? That exponent gets distributed as well. It applies, instead of to each factor, like in the multiplication, it applies to everything on the top, each factor on the top part of the fraction, and each factor on the bottom. So let's simplify a little bit here. What do you suppose this would be written as separate powers? What do I write over here? Anybody? Have a guess? Yeah.
1 to the power of 5.
1 to the power of 5?
And 5 to the power of 5.
Divided by 5 to the power of 5. Exactly. So good job. What's happened is this 5 applies to the 1. So that's a 1 to the 5. And then the 5 also applies to the 5 down there, which is 5 to the power of 5. Okay? Real good. So 3/10, to the power of 2, that's going to be 3 squared divided by 10 squared. Now if I go back to the first page here, okay, this exponent applies to each factor, right? And the exponent shows up twice, and you might think, well, I only have one exponent here, and now I have two exponents. Haven't I changed things? No, you haven't changed things. It's just a different way of writing it. Similarly, for this chart, this 5 that I just wrote applies to the top, and it applies separately to the bottom. So you haven't added another exponent out of midair. You've just rewritten it. And we can confirm this. Let me just try that. Let me show you. Calculator coming up. Virtual TI. Here we go. Okay. So I'm gonna try these two. I'm gonna try turn this on first. Okay, so 1 divided by 5 in brackets to the power of 5. What's that? Now this is scientific notation. You guys know about scientific notation? You ever seen that before? Okay, this is a special way of writing really small and really large numbers, scientific notation. This means 3.2 times 10 to the power of negative 4, or 0.00032. That's what that is, okay? Now, what's important is this. I'm going to do this separately. I'm going to do brackets 1 to the power of 5 divided by 5 to the power of 5. So see, I'm doing this one on the right here. And if I do that, I get the exact same number. Okay? So it's exactly the same. It's just a different way of writing it. Again, 3 divided by 10, all to the power of 2 is this number, 0.09. Well, I wonder what 3 squared divided by 10 squared is. 0.09. Okay? All right. Similarly to for negative factors, let's just do one negative factor one here. So for this one here, this is negative 4 all to the power of 6, because that negative is inside the brackets, divided by negative 5 all to the power of 6. Okay. So the next page there, the exponent law for power of a quotient. You'll want to fill in your blank, which I believe is just this part right here. So if you have a fraction or a rational or a quotient, they call it, and it's all taken to a power, that power applies to factors in the numerator, whether it's 1 or 2 or 3 or 4, and it also applies to all factors in the denominator, so it looks like this. The exponent outside is applied to the exponents on the numerator and separately to the denominator of the fraction inside the brackets. That's what that law says. Okay. Any questions so far? You guys getting this? Pretty easy? Yeah? All right. You guys have been really good to pay attention for 50 minutes straight here, almost. So good job. Okay, let's just do a couple examples here, and then I've got a little bit of a puzzle for you, okay? Okay, negative 24 to the power of 4. Now this is divided by, right? So it's like this right here. That's what that actually looks like. Divided by 6 to the power of 4. Those are some big numbers, so let's try it here. So I'm going to write that negative 24 to the power of 4 is going to be this big number right here. And then I'm going to divide that number by 6 to the power of 4. 256. Okay. Now, let's do bedmass just to check. So what is negative 24 divided by 6? Let's evaluate that first. What is that? Negative 4, right. So negative 4 to the power of 4. Let's check that one out. Bracket, negative 4 to the power of 4. Look at that. 256 as well. So this was the answer we got using our, the first one was the answer we got using our rules. And then this one is also using bedmass. Whoops, 256. Oh, goodness. 256 I have 4 in my brain. Same thing, okay? Good, over here, let's just use our rule, 52 to the power of 3 over 13 to the power of 3. Got it? That's it, distribute it, solve for this, divided by this number, and what do we get? 52 to the power of 3 divided by 13 to the power of 3. 64. If we evaluated that bed mass, 52 divided by 13, when I see 52, I think of a deck of cards. There's 52 cards in a deck of cards, and there's 13 of each suit. So there's 4 suits in a deck of cards. So 52 divided by 13 is 4. So that's 4 to the power of 3, which is 64. All right? Okay, as part of your assignment, there's a little puzzle, just like the pizzazz worksheets that you guys might have just finished here. I'll see if I can get this all on the screen here. So before I give you your assignment, I want you to work through this. It says this, it's a bird's eye view. What is this bird looking at from the top here? So an overhead view of something. If we evaluate each one of these, and then you can arrange the letters to answer this problem. So you guys should have this in your notes. Go ahead and work on that. If some of you have worked ahead and done it already, try not to spoil it for others, but I do want you to show your answers here for each one of these and see if you can solve this puzzle. Okay? So take a few minutes and work on that. All right, so the answers to each one of these, got to be careful that you don't look at the answer. It's the, yeah, you got to be careful here. The letters are attached to these answers. So it should be a person frying an egg. So, well, it's an overhead view. So this would be a person wearing some kind of hat, maybe, or under an umbrella. I don't know. I think this is like the frying pan here. And then that's the egg in the middle. The yolk is not always dead center of the egg. No. But the handle. Maybe the frying pan has been damaged. Okay. Okay. So here's your assignment, part 2. 2. It's big. It's a long one, so I'll recite it while you write it. 2, 4, 5, 8, 10. 13 A, B, C, D,